All right, guys, in this video, we're going to go over the laws of exponents, okay? So in this video, I'm specifically just going to go over the properties and do one example, okay? And then a second video, we'll actually work some other more complicated examples, okay? In this one, we're just going to deal with the property explicitly and not kind of mash everything all together, okay? So first property, any term to the zero power is always going to be equal to 1, no matter how complicated A may be. Okay, if it's all to the zero power, then the answer is going to be 1, okay? So as an example, let's say I've got 7x, okay? And 7x is being raised to the zero power. Again, anything to the zero power is going to have a value of 1, okay? Negative exponents, okay? If you have negative exponents, we need to, what I call, move it through the fraction. So here you've got the a term in the numerator. This is understood to be over 1. Okay, if you move this term from numerator to denominator, then the exponent changes signs from negative to positive. Okay, so a to the negative n is equivalent to 1 over a to the positive n. All right, and no answer, no sufficient answer can have negative exponents. Okay, so you always want to make sure all your exponents are positive in your final answer. Okay, so here we've got y to the negative 2. Okay, y to the negative 2. Well, this is understood to be y to the negative 2 over 1. So we're going to move this y term down to the denominator, and the exponent changes from negative 2 to positive 2. So 1 over y squared. Okay? Nothing else I can do here to simplify that. So that is the answer. Okay? Here we've got the same base. Notice the base here is a to the m power and a to the n power. Okay? So if you're multiplying two terms that have the same base, then you can add the exponents, okay? A to the m times a to the n is that base a to the m plus n. So we're going to add those two exponents. So in my example here, I've got my base is z, and the base here is z. If these are the different, then you can't use this property. They have to be the same, okay? So z cubed times z to the 7th, we're going to add those exponents, 3 and 7, and get 10. So z cubed times z to the 7th is z to the 10, okay? If you divide two expressions with the same base, two exponential expressions with the same base, we're going to subtract those exponents. Again, notice the bases are the same. We're going to do m minus n, okay? So let's say our base here, our common base is x. Because those bases are the same, I can subtract those exponents, 8 minus 5. So x to the 8th divided by x to the 5th is x cubed. Okay, another way to think about that, where are there more x's? Okay, there's more x's in the numerator. What's the difference? Well, the difference is 3. So that's why my answer is x cubed, and that x is in the numerator. If I were to reverse this, x to the 5th over x to the 8th, then it would be 1 over x cubed. Okay, here we've got a power raised to a power. Notice my base is a. We've got m and n here. So in my answer, I'm going to multiply those exponents. The base stays the same, and my exponent will be the product of those two exponents. So if I'm going to raise y to the 4th to the 3rd power, okay, I've got a power raised to a power, then I'm going to multiply those exponents 4 times 3, which gives me y to the 12th as my answer. Okay? In property number 6 here, I've got a product, a times b, raised to the nth power. Well, each factor of this product here has to be raised to that power of n, okay? So a to the n times b to the n. Okay, so both of these terms, if there's 3 factors in this product, then all 3 of those would have to be raised to the nth power, okay? As an example, I've got negative 3x to the 4th power, okay? So I'm going to raise the negative 3 to the 4th power, and then I'm going to raise x to the 1st to the 4th power. And I'm going to multiply those two together to get my final answer. So negative 3 to the 4th power is positive 81. And then x to the 4th I can't do anything with, so we kind of push those together to get my answer, 81 x to the 4th. Okay? A quotient raised to a power. Again, both these parts of the quotient here, a in the numerator, b in the denominator, have to be raised to that power. So a to the n over b to the n. As an example, let's say I've got x over z as my quotient, raised to the 5th power. Well, both of those terms need to be raised to the 5th power. So my answer is going to be x to the 5th over z to the fifth. I can't simplify this because those bases are different. Okay? If I've got a quotient raised to a negative power, all right, then I can do a couple things. I can do what I just did in property 7. I can do a to the n, negative n over b to the negative n. And then I can use my property number 2 here to simplify those and make the exponents positive. Or I can go ahead and flip this quotient first, and that's going to change the exponent from negative to positive. Okay? So a over b to the negative n power is equal to, again, flip that quotient, b over a, and then that exponent changes to positive. Okay? So we're going to use the same problem we did here. X over z to the negative 5 can become z over x to the positive 5, and then we use our property that we just learned in 7, and we get z to the 5th over x to the 5th. Okay? And then if I have a quotient of 2 bases to negative exponents, I can just flip those, kind of like we did up here in property number 2. Okay? So if I've got c to the negative 2 over d to the negative 7, again, notice I can't subtract those exponents because the bases are different. So what I'm going to do is I'm going to move, again, what I call move it through the fraction. The c will go down to the denominator, the d term will go to the numerator, and those exponents will change signs. So that gives me d to the 7th over c squared, okay? And those are the laws of exponents with an example tied into each one, okay? In part 2, the next video, we'll actually work on some problems that are more complicated.